Hi friends, this is PH6503, Unit 2, Magnetic Property of the Material, lecture taken by Dr. M.R. Gadhvi. In today's lecture, we will be focusing on the Weiss theory of a paramagnetism system. Langevin theory is about to fail, especially in idea to understand how exactly the mechanism of a susceptibility and the complications of the susceptibility, especially for the heavier material, more dense material, cold gas material, solid material, solid salts, crystals, etc. So susceptibility was not digestible issue by the Langevin theory thoroughly. So there is a one bridge is needed. Weiss has given the idea about the internal molecular field concept. I think Weiss has given this idea in 1928, and immediately after he also given the molecular mean field theory for the ferromagnetism. Weiss has given the fantastic intuitionally developed concept in his mind, and he has put it into the shape of the mathematical model. And you will be surprised, friends, that this is the fundamental base for the conceptual understanding of the domain, especially in the case of a ferromagnetism. Without Weiss concept, perhaps the domain was not part of the magnetic property or magnetic understanding of the ferromagnetism. Anyway, we will be focusing right now on the Weiss concept for the internal molecular field theory for the paramagnetic material, and he attempted to explain the complications of the susceptibility and its dependence for the material. Now Langevin has took up the analogy of a real gas, and therefore it is treated the material as a paramagnetic gas, and therefore the internal interactions are overlooked. But in the case of a cooled gas or the solid crystalline material or the solid salts, the materials and molecules and their ions are about to be a close proximity compared to the gas analogy or the gas molecular analogy, and therefore one cannot avoid the internal interactions within the magnetic moment, though they are randomly and scattered as well. So magnetic dipole moment, a permanent magnetic dipole moment of a paramagnetic material, they are certainly interact to each other. That was the very clear understanding given by the Weiss. इसीलिए उन्होंने ये शायद इंटरनल मोलिकुलर फील्ड ऐसा कंसेप्ट दिया है. Concept will be fantastic, as I have just highlighted over here. He says that this field is produced at any point. कहीं पे भी आप क्रिस्टल का इंटरेक्शन सोच रहे हो, सो जनरली लेंजेविन थियरी में डी एन ऑसिलेटर्स सोच रहे थे ना, डी एन नंबर ऑफ रेजिम्स दे हैव चोजन among the total available number of n number of molecules. काफ़ी सारे n नंबर ऑफ मोलिक्यूल्स पूरे क्रिस्टल्स में है, उसमें से सिर्फ डी के लिए काम कर रहे हैं इनिशियली, एंड देन यू आर गोइंग टू इंटीग्रेट इट. बट वेस ये बता रहे हैं कि पूरे क्रिस्टल में कहीं से भी आप डी सैंपल लो, फिर भी इंटरेक्शन तो वहाँ पे होना ही है, बिकॉज दे आर द परमानेंट डाइपोल मोमेंट. सो द फील्ड, दिस फील्ड, that means the internal molecular field is produced at any point where the neighboring molecules are available, and it is always proportional, and acting in the same direction of the magnetic intensity. माने मैग्नेटाइजेशन जिस दिशा में शेप ले रहा है, वही दिशा में ये इंटरनल मोलिकुलर फील्ड भी वही दिशा में कार्य कर रहा है, वही दिशा में वो एक्टिव भी है, एंड इट इज़ प्रोपोर्शनल टू द नेबरिंग मोलिक्यूल्स. जितने मोलिक्यूल्स नज़दीक itne intensity stronger, interaction intensity will be stronger. So वेस का ये एक मानना था कि जो इंटरेक्शन अंदर जो हो रहा है विद इन द इंटरनल मोलिक्यूल्स और विद इन द atomic dipole moments, whatever the interaction are taking shape, that interactions are in the direction of magnetization. Number one. Secondly, it is also a proportional to the number of neighboring molecules, and it could be exist at any point. कहीं पे भी आप डायरेक्शन के बारे में सोचो तो मोलिकुलर फील्ड वहाँ होता ही होगा और उसकी दिशा अक्सर मैग्नेटाइजेशन की दिशा में ही होगी, एंड इट इज़ इन अ प्रोपोर्शनल. So that is, he has given the fantastic idea. And let us say that the internal molecular, यहाँ पे readability नहीं है, but internal molecular field is denoted by H suffix I for the internal molecular, and it will come to the next. So Hi is the internal molecular field, is ideally I should write it out proportional to the M, right? Because he said that internal molecular field can exist at any point of the system, number one, and it is always in the direction of the magnetic intensity, and it is proportional. So Hi is proportional to M. अगर मैं प्रोपोर्शनलिटी कांस्टेंट दूर करूँ तो प्रोपोर्शनल कांस्टेंट आएगा, एंड दैट इज़ अ लैम्बडा, एंड दैट इज़ अ मोलिकुलर फील्ड कोएफिशिएंट. लैम्बडा इज़ अ molecular field coefficient, and this is a very interesting and beautiful concept was put forward by the Weiss, and which solved up to a 50% of the conceptual argument of the susceptibility, even for the solid salts, even for the crystalline salts, even for the heavier salts, and so on. Again, it is not the 100% outcome theory or 100% set theory for this one, because ultimately entire magnetization is a quantum concept, and till this Weiss concept, it is still running on the basis of a classical theory. As you are looking that we are still analogy with the real gas system and so on. Anyway, but we are just learning that. So the H is effective. So कहीं पे भी अगर सिस्टम में अगर आप विजुलाइज कर रहे, सो फील्ड इज नॉट ओनली H but some additional field is also acting on it. So external applied field is, let us say, H. So in addition to that, the Weiss concept is a molecular field is Hi is also there, and therefore a total effective magnetic field is given over here, that would be He. So actually you are applying the external field is only H, but within the system, at any point of the system, there is always, because of the close proximity or the there is a adjacent neighboring atom or adjacent neighboring ions or adjacent neighboring dipole moments are interacting to each other, and this is the field is in the direction of magnetic intensity and in the same direction. तो H और in addition to that Hi हो गया. So the total magnetic field is He. अगर यहाँ तक concept सेम है तो बाकी का तो उसमें पूरा ही mathematical derivation जो है that is from the Langevin theory only. So M is given by we are just focusing on the higher temperature range only. Low temperature range के लिए तो काफ़ी cooled temperature के लिए तो satisfied हो ही रहा था. Anyway, so M is equal to Ms into A by 3. A is equal to mu mb by kT, but just to distinguish that induced magnetization is also different than the only B, so I am writing here Be. Okay, and Be will be replaced by mu 0 He. He is here, effective applied magnetic field. So He will replaced by H plus Hi, and Hi is replaced by the lambda M. So M is equal to mu m square and mu 0 3 kT into the bracket H plus lambda M. If you expand this, just take care, in the book there is a mu is missing, so I put the question mark here just to bring it to your notice. By chance you are reading the book just add mu 0 over here. Okay, so when you are doing this, so this is your basically m into lambda, so mu 0 nh upon 3 kt mu 0, that is your m magnetization here into lambda. So this m is shifted to the left side, so m can be taken as a common, and that is what a derivation is shown over here, that 1 माइनस म्यू स्क्वायर एन लेमड़ा 0 म्यू 0 3 के टी 1 माइनस, क्योंकि ये m यहाँ से आया था, m मैंने कॉमन लिया, और दिस इज एज अ डिनोमिनेटर पार्ट ओनली. सो एनीवे, so this is like this. And finally the equation, if you are still confused with this, then please give me a WhatsApp. I can give you the write up. I think you can do it. I think your TI guys, you can easily handle it. So I can put it even in the normal paper, and I can put it a slice, additional slide to just understand the derivative. Just give me a WhatsApp if you are not understanding this set of equation. Okay, so m is equal to n mu 0 mu m square h by 3 kt. I am taking as a, this 3 kt is coming here, so 3 kt 1 minus mu 0 and lambda mu 0. I am writing precisely everywhere mu 0 where it is missing, but you just take care and do it one calculation once. And then yes, so what is special about this? If you look at that, this is almost done. So n mu 0 mu m square, n mu 0 mu m square, this h I am taking on m by h over here, so I can having a volume susceptibility, and n mu 0 mu m square 3 kt, then t I am taking inside, so 3 kb is only outside, so t is here, and then mu m n lambda mu 0 by 3 kt is everything is there, so this t and this t will get cancelled. So over here there is a all constant parameter. कोई भी सिस्टम के लिए mu m constant रहेगा, n is available number of atom constant रहेगा, ये तो इंटरनल मोलिकुलर फील्ड कांस्टेंट या तो वेज कांस्टेंट लैम्बडा है ही, 3 kb permeability mu 0, everything is constant, and therefore it is written as a theta c. So this is a Weiss theory, and mu 0 mu m square 3k into t minus theta c. In some book it is written as a Tc also, Curie temperature, here it's a theta c. So that is it is written where theta c is called the paramagnetic Curie point. So in this way many large range of the paramagnetic material are answered very correctly, and their empirical data and theoretical data are matched. But still Weiss theory is not the final one, because मैंने पहले भी आपको बताया कि पूरी मैग्नेटिक सिस्टम है वो क्वांटम कंसेप्ट है, और ये सभी थियरी है वो रियल गेसेस या तो के क्लासिकल कंसेप्ट पे है. सो नेचुरली यू आर नॉट गेट द 100% आउटकम ऑफ दिस, बट स्टिल compared to Langevin theory it is very nicely answered. The very compressed and the mini salts, many crystalline materials are answered by the Weiss theory. But still there is a one very technical hitch you can see. अगर Curie point, अगर Curie temperature is below than the applied T, then your susceptibility will come to the negative, and this leads to a wrong indications in the paramagnetic system. Generally susceptibility negative माने डायमैग्नेटिक होना चाहिए. तो यहाँ पे एक माइनस ये आ रहा था कि अगर द स्ट्रेंज कंक्लूजन ऑफ अ Weiss एनालिसिस, मैंने येलो स्ट्रिप्स करके थोड़ा हाईलाइट किया है, द स्ट्रेंज कंक्लूजन ऑफ Weiss law finalize that below paramagnetic Curie temperature, माने अगर T is less than theta c, then susceptibility become negative. अगर आपका मेजरमेंट ऑफ अ T अगर वो बिलो Curie temperature का से है, तो आपका T will becomes to negative. T छोटा रहेगा, theta c larger रहेगा, so this difference will be the negative, and your overall susceptibility become negative, or negative susceptibility is contradict with the concept of the paramagnetism. So यहाँ पे wave theory थोड़ी सी नहीं, I mean conceptually fails हो रही है. So this is not a universal theory for all paramagnetic material, but yes, a very large chunk of a paramagnetic material are covered and answered compared to Langevin theory, right? So with this I am stopping here. Very small concept. In addition to this theory, there is a one more conceptual theory of a paramagnetism is still there, and that is about the paramagnetism of a solids. And that also I will upload the lecture, and that would be the syllabus of the CIA 2. So lecture 3 to lecture 3, 4, 5 and 6 is the syllabus of the CIA 2. Stay home, stay safe, take care of yourself, and all the best for exam.